Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have k divided by 3 is equals to k, and we solve this problem for all the values of k. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, at the last I can explain the difference between a solution and extraneous root. So please watch this video at the end. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move towards the solution of this problem from first method. And here in the first method you see that this 3 is divided by left hand side. So when we move it into the right hand side, it is multiplied by k, or in other words, we multiplying both of the sides of the given equation by 3 on both of the sides. So when we multiply it by 3, it will be written as 3 multiplied by k over 3 is equals to 3 multiplied by k. And now here further in the next step you see here this 3 and this 3 are cancelled out by each other, and we get the remaining values are in the left hand side we get k only, and in the right hand side we obtain 3 times of k is equals to 3k. And now further in the next step we move this k from left hand side to the right hand side, and it will be written as 3k minus k is equals to 0. In the next step you see here both of these two terms involve k. So in other words we say that both of these two terms are the like terms. So here we need to subtract both of these two values, and you see here 3k minus k becomes here a 2k, and this whole equation is equals to 0. And now here in the next step we need to divide both of the sides by 2, and when we divide by 2 it will be written as in this form. And now further in the next step you see here these 2 and these 2 are cancelled out by each other, and in the left hand side we obtain k is equals to, in the right hand side we have 0 divided by 2 becomes here 0, because we know that when we divide 0 with any other number it will remain 0. So here we easily get the value of k equals to 0. So in the first method we get only one root of the given equation, and this is k equals to 0. And now here in the next step we need to verify that is this value of k be the solution, or is this value of k be the extraneous root. So for this we need to copy down given question statement. Here it is k divided by 3 is equals to k. And here in the left hand side we substitute this value of k here, and when we put it here it will becomes 0 divided by 3 is equals to 0, and this implies that 0 divided by 3 becomes here 0, because I already explained that when we divide 0 with any other number it will remain 0. So here we easily get the value, easily get both of the sides are equal. So if both of the sides are equal, this means that the value of k equals to 0 is satisfied our given question statement. So we call that k equals to 0 be the solution of the given equation. So we write it here, the solution set of this problem is k equals to 0. So here I can explain the difference between solution and extraneous root. So you know about that the roots which is satisfied our given question statement is called the solution of that equation, like we have k equals to 0, and the roots which does not satisfy our given question statement is called the extraneous root. But unfortunately in this question we cannot have any extraneous root, we have only solution, and that is k equals to 0. And now here we again solve this problem from a second method, and in second method we need to copy down given question statement here, so that now our given question statement is k divided by 3 is equals to k. This is our given question statement, and here we use the LCM technique to find the roots of this equation. So for this we move first this k into the left hand side, and it will becomes k divided by 3 minus k, and this whole equation is equals to 0. And now you see here the denominator of this term is 3. Now we need to make the denominator of this term is also 3, And for this, now we multiply and divide this term by 3. So we write this term in this form. So we multiply and divide it by 3. And now here we can easily make the LCM of this term. And you see that the LCM of this term is 3. So this 3 and this 3 are gone, and we get here k minus this 3 and this 3 are gone, and we get here 3k, and this whole equation is equals to 0. And now here in the next step we need to subtract these two values, and we obtain here k minus 3k is equals to minus 2k divided by 3 is equals to 0. So here we need to find the value of k. So for this we multiplying both of the sides by 3. So when we multiply both of the sides by 3, it will be written as in this form, and here we have 0 is multiplied by 3. So this 3 and this 3 are cancelled out by each other, and we obtain here minus 2k is equals to 0 multiplied by 3 becomes here 0. And now here for the values of k, we need to divide both of the sides by minus 2. So when we divide by minus 2, it will become here this minus 2 and this minus 2 are cancelled out by each other, and we easily get the value of k equals to 0, because you see that 0 divided by minus 2 becomes here 0. So in the second method, you see here we again get the value of k equals to 0, and in the first method we already verified that this value of k is satisfied our given question statement. So finally we have the solution set of this problem is k equals to 0. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.